Good morning, everyone. I'm pleased to welcome all of you at our webinar on concrete recycling, upcycling, and actually using debris as a new construction material for the reconstruction of Ukraine. I am Roman from ReThink, and we are an NGO that is promoting circular economy. And in particular, we try to ensure that the reconstruction of Ukraine is as much sustainable, as much circular as possible for a better world, but also for a higher quality of life in Ukraine after the victory. And if we talk about concrete recycling, concrete upcycling, we at ReThink always try to bring the best possible expertise to Ukraine. That's why we have C2CA from the Netherlands with us. And for Ukrainian participants who do not understand English, для українців, які не розуміють англійську мову, можете брати переклад внизу свого екрану, натиснувши на
in the bottom of their screens, they can select the appropriate button.
And choose Ukrainian for translation. Also, while we have C2CA from the Netherlands as a pioneer in concrete recycling, I would like to express my gratitude to the Embassy of the Netherlands for making this possible and for supporting our event. And for the introductory word, I would like to invite Mr. Jörg Zinken, who is coordinating the reconstruction efforts from the side with the embassy, and who is also the deputy head of economic section in the embassy. Thank you very much, and the floor is yours, Jörg.
Great, thank you so much, Roman, for giving me the floor, and thank you first of all to ReThink and C2CA to take the time today to organize this this event together with indeed the Netherlands Embassy. It's a great pleasure to work together again and work together on the future of Ukraine, and in this case specifically on the circular economy. And let me start by saying that I was in Warsaw last week in the at the Rebuild Ukraine conference, and I felt a lot of energy there to start working on the rebuilding of Ukraine and on the future of it. And I think a circular economy should be part of that future of Ukraine. So I'm very glad that we can have this event here today, and especially thanks to Thomas and Michael for taking the time. I understand for Thomas it's very early in the morning, so thanks a lot for being here with us. You might not be in a suit and tie as myself, but it's quite late here in the morning, so it's you're excused for that. Well, since the beginning of the full-scale invasion last year, we've been witnessing how Russian attacks don't just kill people and destroy homes, but they turn entire city into ruins and nearly completely leveling them to the ground. Then we're talking about Mariupol, Bakhmut, Severodonetsk, and unfortunately many more cities that have been destroyed by the Russian attacks. Left behind, we encounter piles of construction debris, bricks, concrete, glass, furniture, plastic, and whatnot. Ukraine's Ministry of Environment estimates that the amount of destruction waste created in Ukraine by Russia's war in the past year is nearly as much as the amount of solid waste generated in the entire country in an average year, and equals to about 10 to 12 million tons. Most of the communities that faced large-scale destruction now solve the problem of disposal and recycling of construction waste on their own. For the most part, the solution is limited to removing debris and removing the remains of buildings to temporary storage sites, where all of it usually ends up in one mixed pile. If not handled in a smart way, this can lead to disastrous consequences, causing even bigger problems, both for the communities and the environment. Therefore, the key solution in this situation might lie in effective introduction of a closed cycle economic principle, one of them being recycling of construction waste into new building materials. The latter is rather innovative for Ukraine and thus has enormous potential. It could ensure recovery and rational consumption of resources, as well as minimize the negative impact on the environment. Apart from that, it could stimulate creation of modern urban neighborhoods, which would be fully or partially constructed using recycled demolition waste. Although recycled construction waste will not always become a new house, it can serve other purposes just as much. To name one, it might very well be used to construct roads, one of the main, of course, issues for Ukraine at the moment. In the Netherlands, for example, already today, 97% of construction and demolition waste is being reused, as a result of which new circular materials and technologies become available. Along with it, we notice development of new business models and collaborations that have the potential to transform each and every element of the urban system to a more sustainable one, accelerating this way the process of transition to the circular future. By supporting this webinar today, we hope to share with you one of the showcasing examples of innovative solutions that the Netherlands has to offer in the field of concrete to concrete processing. So we're very happy again that we're having this meeting today. I will not keep you any longer from hearing all about the C2CA technology, and I would like to thank you all for joining us here today and pass the floor to our experts who have actually something more specific to say about the technologies. Thank you so much.
Thank you, Al.
Let me introduce myself. I'm Michael Green. I'm an Irish-American living in Rotterdam. In fact, I'm on the lovely Koolhaven River, just off the River Maas here in Rotterdam. And I've been working with C2CA since the beginning of the year. And in fact, going back to what Thomas said, and I'll just see what you're seeing on screen is actually our demo facility in a town called Hoorn, just north of Amsterdam. But the kind of the history of the company, Thomas gave you an idea of the technology a little bit, although I'll get into that. C2CA is actually a startup spin-out from the Technical University of Delft. So speaking to Jorg's point, this is a Dutch technology and it's being perfected here. But as Thomas mentioned, we're eager to get into other countries, and in particular, the Ukraine gives us a unique opportunity to process a lot of waste, end-of-life concrete waste all in one place. But before I jump into the presentation, I just want to say a few things. Number one, Slava Ukraini. We really respect the grit and courage of the Ukraine. We hope you join Europe soon. Secondly, I'll try to speak slowly for the translator. And thirdly, I prefer interactive presentations. So at any point, if anyone has a question, please feel free to put in the chat what your question is, and Roman will stop if he thinks it's a pertinent question at the time. So in this presentation, I'll show you sort of some overall figures. I'll give you a sense of what concrete recycling is like in the Netherlands. And then we'll talk a little bit about the Ukraine, and then we'll talk about what drives the success in the Netherlands. And then I'll tell you a little bit about the technical properties of actually using recycled concrete, what we call aggregates. And on one slide, I'll show you a list of terms, because we love our acronyms. But without further ado, just a look back to C2CA. So really our mission and vision is to phase out the use, well, as you can see, of virgin materials. What that is to say is we don't want to keep quarrying stone and taking sand out of our rivers. We'd like to reduce the use of virgin materials. In fact, the numbers don't add up. For the time being, it'll be a mixture of both, but what we'd like to do is massively decrease the use of virgin materials that impacts our environment. And we would like to make concrete a fully circular system. And that's to say that all of the old infrastructure, kind of the business model for us is the old infrastructure in Western Europe and the United States is coming to end of life. So there's a huge supply of end of life concrete, and we'd like to put all of that right back into concrete to rebuild that infrastructure. Obviously in the Ukraine, you have a high amount or a large amount of this waste concrete that we would be very eager to help you put back into new buildings, to rebuild the Ukraine in a circular way. Because I can tell you as a non-Dutchman in the Netherlands, it's very interesting to see, and we'll talk about this later in the presentation, how the culture of the Netherlands is to recycle everything. I might step back and say there's a joke here in the Netherlands that God made the world, but the Dutch made the Netherlands. And that is to say, they don't have any space to landfill. And over 20 years ago, government, civil society, and industry agreed that they would not landfill any end-of-life concrete. They would recycle it all. And as Zorg said earlier, 97% of concrete and demolition waste gets recycled. The 3% is just can't be recycled. So it's asbestos and other things that has to be disposed of in a different way. But having the culture of recycling is going to be a very important component, which we'll get to later in the presentation. So a couple of slides just to give you an overall idea of why this needs to happen and what the global numbers are. And I'll say at this point for everyone, we all talk cement and concrete, and those words get used interchangeably, and they really shouldn't. And I like to use the metaphor of a cake and flour. Cement is the flour, and concrete is the cake. So what you see in the world is concrete. You don't see cement. Cement is only, in fact, about 15% of concrete, but it produces 90+% of the greenhouse gas emissions of the cement and concrete industries. So really the goal of C2CA, aside, there's two goals: to make concrete fully circular, but we want to reduce the use of cement because that's where the biggest circular impact on greenhouse gas emissions comes. The more cement you can reduce, and we can do that by recycling the cement paste, the better impact we have on lowering greenhouse gas emissions in the world. So this is kind of the global view. We don't have to spend a lot of time on this. Again, Western Europe and the US, post-World War II infrastructure coming to end of life. Ironically, China is actually already rebuilding some of their 1980s and 1990s, early 1990s infrastructure. So they have a huge amount, but this is just a quick global view. So now I'm going to give you just a little specific deeper dive into what end-of-life concrete recycling looks like across Europe. This is a little bit of a complicated graph, but I'll walk you through it. On the left side, you have percent of recycling of concrete and demolition waste. Along the bottom, the x-axis, you have the amount. So you can see the Netherlands recycles virtually 100%, and they're at about 20,000 tons per year. Germany, as you would expect, leads the pack, in France. They're at 60,000 plus. Now, the color and the size of the circle speaks to the processing of the waste. So while France does process, recycle a lot, they don't process it effectively, whereas Germany and the Netherlands process it more effectively. But I can tell you from real world experience, in fact, Germany probably doesn't deserve that big green circle because most of what they recycle, they downcycle, meaning they just crush it and they put it into roadbed, although the Ukraine will definitely need to do some of that with recycled concrete, but they don't upcycle it into new concrete for buildings or bridges or other infrastructure. So the Netherlands actually leads the world undeniably in the upcycling of concrete. And I'll get into more statistics later, but here's actually the graph. You can see the whole EU here. And again, Slav Ukraini, we hope to see you on this table soon and near the top, not the bottom. But I put this here just when we share the slides later. There's a little bit of interesting reading just to see who's doing what in concrete recycling across Europe. But what I would say is again, there's recycling, but there's inside of recycling, and you'll see this on some of the next slides, there's downcycling and then there's upcycling. If there's any questions, feel free to put them in the chat because I hate to hear my own voice for too many minutes in a row. But as mentioned earlier, these are numbers from Natalia Lushnikova. She's actually a Ukrainian PhD student at the Technical University of Eindhoven, with whom we work. So Technical University of Delft, Technical University of Eindhoven are two of the world's leading institutions in researching the recycling of concrete and other building materials. But yeah, 10 to 12 million tons as of the invasion to May. So we know that's gone up. There's some numbers published in September. They weren't easily accessible to me, but just in terms of perspective, obviously you would be kind of in the middle of the pack or a little bit below the Netherlands in terms of the amount. So here is kind of definition of terms, and this is important when I go through the technology. Let's step back for a second. What's concrete actually made of? As mentioned, it's about 15% cement powder, the glue that keeps it together. And then it's stone and sand and other filler materials. So obviously that's what we're going to recycle out. So we call the stones recycled coarse aggregate, RCA. The sand is called recycled fine aggregate. Now, when you crush, and you'll see this in a second, the first step of recycling concrete is just to crush it from its previous form as a pillar or as a floor or a wall segment. You get the stones and the sand covered in the RCP, or the cement paste. And what we are endeavoring to do is to separate those all out in a very clean way. And as Thomas mentioned, one of the challenges of the industry is to do that in a way that meets the quality requirements of the people who then want to buy that stone and sand to put back into the new concrete. But in fact, the last two terms are probably where we have the biggest environmental impact vis-a-vis greenhouse gas emissions, because where we really want to get to is what they call an SCM, or supplementary cementitious material, meaning a cement replacement, because we want to produce less cement, which will bring down the greenhouse gases. And you'll see in a moment what the difference is between recycling the cement paste and creating new cement. So again, recycled coarse aggregate are stones. Recycled fine aggregates, sand. The process is to get the RCP, or recycled cement paste, off of those two elements so that we can process that and put the stones and the sand back into concrete. So this is what the process is. At the top, this is currently what most people are doing. You've built the building, it's end of life, you demolish it, you crush it. I've used that term a few times. You literally put it into a machine that there's a few different types. Although what we've found is you have to be better at crushing if you want the quality that you want and the end result. But in any case, today you crush it. Some places it goes into landfills. I think Ukraine might be one of those. And downcycling, what we call downcycling again, it's into roadbed or underneath foundations, which is needed. And that was a great initial application. But we feel, if you look at the bottom, it's to upcycle it and make this a fully closed loop, because then we don't have to use virgin materials. We're using less cement, and we're not defiling the environment. Again, if anybody, it looks like there might be a couple questions in the chat. Roman, do we want to address any of those?
Yes, Mike, we do have quite some already, but all of them are not yet related to the content you are talking about right now. So I would address them a little bit further.
Okay. So now let me talk about, somebody raised a hand.
Pani Elena, please. How do we do that?
I think she has to put the question in the chat. I don't know if she did that.
Yeah, I think so.
буде краще, якщо ви могли б записати своє повідомлення у чат. Мені здається, так буде зручніше.
Yeah, absolutely, absolutely.
Ну, будь ласка, запишіть ваші зараз питання у чат. Роман міг би їх прочитати Майклу, і Майкл вам відповість.
Do you want me to keep going, or do we
Yeah.
have something to address? Is
Yeah,
there a
yeah.
question?
No, it's silent, so you can keep going. Yeah.
Okay. So now this is a little plug for the company. What you're actually seeing are the new technologies we're bringing to market. So what you saw from the previous slide is the end-of-life concrete is crushed and then used for roadbed. Well, in the Netherlands and a few other countries, they actually take the crushed concrete and then they try to separate it with current technology. And the current technology is what they call screening or sieving. You literally put it into the bucket, a big bucket that shakes, and you have different screens, and it does separate out some of the stones and some of the sand. And they use about 60% of that as what the coarse aggregate. So basically they can get stones out, but they can't get any sand or concrete paste out of it. So the first machine you see here, what we call ballistic separation, is instead of using a bucket that shakes, we're using a drum. We call it ballistic separation, which allows you to get a better separation of the different materials that come out of the crushing process. And importantly, you can get more of the finer materials out, which you then want to take and put in what we call thermomechanical separation, or the Haas, heated air separation, which is the middle machine with the green dynamo there, is that you heat it to crack the cement paste, and it comes off of the sand and some of the smaller stones. And in fact, the sand we're talking about is more stony sand than desert sand. It's actually the small, fine riverbed kind of sand particles, but you want to get the cement paste off. And then the third piece, and this is extremely important, is you have to guarantee quality control. So we are using a laser interferometry system to track what is actually in the waste. So what Thomas had said earlier, we don't know what's in the waste. We would be able to track it. And the big thing you want to avoid is asbestos. And as far as we can tell, you don't have that problem. Other countries do. But you definitely want to avoid the asbestos, but you also want to know how much wood you have in there. And as this becomes more of an industry, you will then be able to grade different levels or different batches, of a different level of quality. And you can actually put RFID chips. I'm not sure if people are familiar with that technology, but you can actually say, this is a high quality batch, this is a medium quality batch, this is a low quality batch. So that instead of having to try to perfect each batch, you can take in different qualities of end-of-life concrete and sell them as the marketplace wants to consume them. But again, let's go back down to the bottom, and this shows you a picture. This is roughly what waste concrete looks like on the left after it's crushed. And the ballistic separation will get you the coarse aggregate, so 4 to 12 millimeter. And in fact, it's the stones, but you'll still have some cement paste on there. But then the fine aggregates, again, it's that stony sand. And again, you'll have some cement paste on them. The large pieces, we would not use the heated air separation method. The smaller pieces we would, which we then liberate, what we call ultrafines, which is, smaller than a millimeter, obviously. And the smaller you get the particle, the better it is for your concrete, because in the concrete, you want to fill up all the spaces between the different stones and sand particles. So the name of the game is to get it finer for use in the new concrete. So I'm just going to show you it again, but I'm also going to show you now the difference between creating new cement. And they use the word clinker. That's kind of the base material. But for new cement, it's roughly 1 ton of CO2 goes into the atmosphere for 1 ton of cement, roughly. I mean, the official number is 900 kilograms, but it's 1 ton for 1 ton, roughly. For 1 ton of the SCM, or supplementary cementitious material, we're saying it's less than 20. We're still confirming that 11, but it's very, very clear to us once our process is optimized, it's an order of magnitude lower CO2 into the atmosphere to develop those SCM. So it's the upcycled cement substitute, really. That's that ultrafine element. And there's a few more steps. For anyone who really wants to do a deep dive into the technology, we'll sign an NDA and we're happy to share. But again, we hope to get an installation sometime next year into the Ukraine, but we're still working on those details. But you can see clearly the environmental impact. The greatest environmental impact we can have is to recycle that cement paste. I see more activity in the Q&A there, Roman. Is there any?
Mike, yes, I was going to stop you because we have a technology related question already.
Go for
it. Before we move to the next block. So in general, why do you think downcycling is the preferred way now for like most countries? Is it just the lack of awareness, or are these some additional costs or hardships associated with the recycling or upcycling? Thanks. And Stanislav, please put your question to the Q&A because we don't know how to let you speak, and that would take too much time, I guess.
So I think there's three reasons. One, the downcycling is the easiest, and I'll explain why. Typically, a developer, a real estate developer, owns the old building that has to be demolished, and he or she or that company wants to put up the new building. And very quickly, they want to get that building down and the new building started. So the easiest thing for them to do, the majority of large projects are crushed on site. So the easiest thing for them to do is to just sell that off the cheapest possible way, because for them it's a cost. They just want to get rid of it. So it's just easy for them to crush it and put it into the roadbed. Number two is technologically, the technology again is crushing and then some form of physical separation, screening or sieving currently. It's only so effective. You will never get the SCM. You'll never get to this point of offering the market a cement replacement product. So there's not a huge profit margin in the upcycled materials, the stone and the sand. That's number two. And number three, government regulations are not currently demanding it. They're just suggesting that you'll get, and I'm going to talk more about this later, you will get more. In fact, it's a combination of government regulation and the kind of civil engineering and construction culture is inherently conservative. And until the rules say you have to use circular materials, and I'll again talk more about it later, but right now the industry here in the Netherlands is just trying to figure it out. And there's a huge desire to use it. Customers are now demanding at the endpoint. So you're seeing the shift away from easy, low profit to it has to be circular. Does that answer the question, Roman?
Definitely yes. Well, at least for me. But there is one more, actually two more probably on this part. So the general one, what kind of technologies are there to upcycle debris that are poisoned, that contain industrial waste?
So yeah, industrial waste is separate category, although I can speak to it a little bit. In fact, and it speaks to the C2CA technology. Again, going back to ballistic separation, and there won't be a quiz or a test at the end of this, but the the ballistic separation unit actually started life in 2011 as a processor of incinerator bottom ash. And what that is here in the Netherlands, a lot of electricity is generated by burning urban or industrial wastes. And the problem existed of what to do with the residue, because there actually was value in there. There's metals, copper, gold, other materials that you wanted to recycle. So again, this was at TU Delft, was the same department that developed the concrete recycling separation. It was built on top of the technology they used to figure out how to separate the incinerator bottom ash. Now, what happens is, with incinerator bottom ash, you get many more sets of materials, and I'm not an expert on it, but generally they have figured out how to use most of it. But there are certain things, again, like asbestos, that you need to separate out, gypsum, you need to separate those things out to either be used only in the way you want to use them, or they just need to be landfilled the tiny bit or processed in a way that they become inert. I hope that answered the question, because industrial waste is a much bigger processing issue, because then you can also talk about chemical industrial waste, which I'm definitely not an expert in.
Yeah, I'm afraid so, yeah. One more would be there as well, and it's a long one, so I'm gonna read as it is. Quality control will be an issue in Ukraine with the rubble processing. We have asbestos widely used in the past, and in brackets, I want to note that it's mainly in low-rise buildings and private buildings, not like the huge buildings. The debris will contain also a lot of WEEE bits and furniture, plastic, glass materials. How difficult is it going to be to bring the quality up to upcycling use level, and what will be the limitations for upcycling applications due to low quality?
Those are great questions. There's a bunch of questions there, and I'll answer it. Well, so again, I'm jumping ahead in the presentation, but I think what's made the Netherlands the world leader in concrete and demolition waste recycling is they had an agreement between government, civil society, industry, and basically end user consumers to say, we're going to figure out this problem. We're going to recycle everything. And so as a result, the starting point for this process is demolition. And so the Dutch are the world's leading demolition experts now. I mean, I know many of the Dutch companies go into different parts of Europe because they're just the best at the game. So they know how to take all the waste out of the concrete, or the wood, the copper, the plastic, the windows. They have a very effective demolition method. So here, the mixed waste problem isn't as big as it will be in the Ukraine for sure. But having said that, there are still some really dynamic companies here, both big and small, or regional players and national players, who have very effective methods of actually combining, and it's not industrial waste streams, but again, it's just concrete and demolition waste and all the materials that he mentioned, where they combine the crushing, the sieving, but there's also a washing step, there are hand picking steps. So the Dutch have really figured this out. You can get to the ability to separate it out, and also, again, talking about the interplay between industry and civil society and government, they're changing the building standards to allow different kinds of aggregates to be used in different kinds of applications. So kind of the perfection of, we're going to have clean stones and clean sand. You don't need that for every application. Yeah, for a tall building, probably. But for roadside curbing on a highway, or for a sidewalk, or for any other much lower risk applications, you don't need perfect aggregate at all, in fact. So I would say maybe the final answer, and sorry for rambling, the Dutch have figured out how to separate all that. There are a few players that are really advanced in just taking a pile of mixed waste and separating it all out, including using optical sensors to get the end-of-life concrete out and move the wood over there. Very interesting processes. So I guess the answer is it can be done. It can be handled. I've seen it in action. I mean, over the summer, I did a market research report for the board of C2CA, and I went out and visited a lot of these, and we have a few more visits planned. And it's really impressive, the systems that they have. You know, it includes a washing step, again, a hand picking step, and they've automated the process. So I hope I answered that question. Sorry for rambling.
Yes, Mike, thank you. I guess we could move forward a bit and then come back to Q&A again.
Okay. So I've been speaking to this, you know, for the last few minutes. You really need industry and government sets the standards, and industry has to accept them. So I've been holding off on saying this, but here in the Netherlands, for most applications, you can use, and I'll show you some of the applications we've tested out in the real world at the end of the presentation. But in most applications, you can use up to 100% recycled aggregates, meaning the stone and the sand. Now, there are a couple providers of concrete that are saying they're fully 100% circular. I would debate that with them strongly, but it seems to me what the market is accepting right now is 30%, maybe 40% for recycled aggregate use in concrete. Just because the building standards, the government's saying clearly go for it. Industry is saying, okay, we're still learning, we're still testing. But the good thing is there are ways to test this, and we're doing this all the time. You know, every week we're doing new tests, and we're actually with the government ministry who manages the canals and the river infrastructure. It's a contest. It's an opportunity for us to. We did a couple of years ago, and you'll see a couple of the examples at the end. But they're asking us to do it again to see if, you know, we've improved our process. Does it change the performance of the concrete? So, you know, the technology I'll get to in a second, but I think what we see as barriers to entry, but also as a solution, is truly the interplay between government agencies saying, go do it, you know, in a safe way, to de-risk it for the industry, for the civil engineers, for the construction companies. And actually, I would say the triple helix is actually industry, government, and the universities. Like, help pull that new research out of the universities and get it out there. And you have to have those three players, you know, and the university representing the technology, working, you know, hand in hand to make this happen, because it's a slow transition. And although the Netherlands, I think, has done it lightning fast, but even now we're still in this chicken or egg moment. So I think we hope at C2CA that once we're able to say, hey, we're recycling the cement paste into a cement replacement, we think that'll really help accelerate this process, because that's where there's a lot of profit. So earlier, you know, why is everybody downcycling? But there's just not that much money because the cost of natural aggregates are still low. But there's two industries here. There's cement and concrete, and many of the concrete players they're not also cement players, meaning they'd rather not have to deal with the expensive cement that they have to buy. They want replacements. So there's big demand in the concrete, the actual people who mix it and deliver it to your job site. And I think once they see that there's value in extracting that cement, because, you know, just round figures, a ton of stone will cost you, let's say, 20 euro. It's a range, 15 to 25, let's say. But let's say it costs you delivered 20 euro a ton. If you can get an SCM, a reactive cement paste, you know, then we're talking 40 euros a ton, 70 euros a ton, because cement is about 150 euros a ton. So you can start to see the economics, and everybody is going to want that SCM, but then they're going to have the stones and the sand. And I think then it becomes more of an industry. And And hopefully we will have had a lot of successes showing, and I'll show you later from our testing, there really is no difference between recycled aggregate and natural aggregate. Roman, do you want to talk about anything here?
Well, just maybe to underline this legislative norms about what percentage is allowed for the aggregate and for the yeah, for the
SCM. But yeah, so the SCM is separate. That's a different. So there's no 100% with that, but with recycled aggregates, the stand and the stone. And where is it now? In fact, Roman, you and I have talked around it a little bit, but what are there any regulations about the use of recycled aggregates in the Ukraine?
Well, I believe currently it's a little bit of a mess because we have a certain regulation that allows to experiment due to reconstruction and la la la. But overall, I guess it's not more than I don't want to lie, but it's some kind of nearly 6% or 10%, something like that.
Mm-hmm. So do we want to talk at all about many of the conversations we've had over the last few months with some of the university players and what's going on in the Ukraine, or do we want to leave that for a later webinar?
No, I think we can leave it for later, but it's just important to underline that in the Netherlands you can replace 100% of the aggregate and up to 20% of the paste.
That's correct. But 20% of the cement mix. Yeah.
Yeah, cement mix.
Yeah. So again, here are the Dutch facts. You know, and about 20 years ago, they just agreed no landfilling, and we're not making our problem somebody else's problem. So I can tell you, and this Roman and I talked about this yesterday when we were going over the presentation. While this started more than 20 years ago, the Dutch are increasingly challenging themselves. And there's something called the Beton Accord from 2018, where industry agreed with government and civil society that they would accelerate the transition. So, I mean, we've all seen all these numbers, but the Beton Accord in 2018 said by 2030, we want to be more aggressive, and we want to make our concrete 100% recyclable or circular by 2030 as an industry and as a country, as a nation. And so now government tenders, if you're not trying to sell the government for infrastructure projects concrete using recycled aggregate, you get I want to say demerits. You'll get rated lower. So the recycled aggregate, you get rated much higher. You can pitch it because maybe we won't have enough, but the people, the companies pitching the recycled aggregate will be ranked higher on tenders. And in fact, it's already happening now. The concrete companies are becoming somewhat expert at what's called an LCA, or lifetime carbon analysis, meaning what's the carbon footprint of this concrete? Where does it come from? And I'm now starting to hear people say, well, I think they're lying. Well, lying. There's competition about how you judge these things. So that when the concrete business, to get their business, have to be responsible carbon citizens, if we want to call them that, I think that's a huge leap forward, because now the industry will really be driving this. Whereas it's been universities and governments driving it. Now I think you're going to start to see industry drive that. But having said that, and I'll show you a slightly depressing slide next, but an opportunity slide. In reality, there's about 24 million tons per year of concrete and demolition waste in the Netherlands. But our estimates are only about 3.3 million tons of that is really upcycled. So the vast majority, even in the best country in the world, is downcycling the concrete, to the question earlier, Roman. So, you know, for C2CA, that just shows the huge opportunity and really it also speaks to the technology gap and why we need to invest in the C2CA technology, because there's a lot of people in the cement or the concrete industry chasing the SCM or the supplementary cementitious material, but C2CA is one of the only ones actually taking the old cement paste, recycling it back into that process. So again, huge opportunity. And here's another slide again. There's an estimate from back in May that maybe 6% has been recycled. So for me, instead of saying shame on you, I say huge opportunity, because we know we have a lot of concrete waste, rubble from the war. So huge opportunity, which is why the Netherlands, and I hope that we'll follow up with Jorg, Roman, to discuss that, because I think there's a great opportunity for the Dutch recycling industry to make a huge impact in the Ukraine, to really set up that circular economy. Are there any other questions? I see a few more on the Q&A poking in.
Yes, there are.
Well, I'll stay with this
so
one.
Some of them, yeah, I don't think it's about this one, but so I will leave the financial questions for the final discussion. Yeah. There is. Please share a sample of concrete mix design with recycled components, if possible.
Yeah, that I can't do, and we all know that.
No?
Well,
oh, that's strange.
Yeah, well, yeah, I don't have one up my sleeve.
Okay.
But it's funny. That's a good question, because we've actually discussed at C2CA coming up with some of our own mixes, but the whole mix thing, that's a whole other category of conversation. But it's a great question. It's a great question.
Is there other standards already in place for secondary aggregates applications in building materials? Yeah.
In both Europe, EU wide standards, and then each country has their own standards. But the EU, the Netherlands leading in this, and again, in most applications they'll let you go 100%. But I mean, I can share those applications. I mean, I can share that with you, Roman, and you can share it out to the crowd. For those regulations. But yeah, there are regulations about this. And there's two sets of regulations. There's about recycled aggregates, and then there's the use of SCMs, cement replacement. So aggregates, 100%, let's say, or a high number. SCM, it's only 20%. Europe right now is only saying you can use these other materials to replace 20% of cement, and we're lobbying to get that to 30. But anyway, we can share a lot of that information if you'd like.
Yes, and also on that matter, another question comes: what kind of documents on the governmental state level, well, basically regulate the use of waste, regulate the use of waste in whatever future usage, reuse. So I guess that's a very wide question, because it's not even specified that it's demolition waste, so it's all kind of waste. Yeah,
I mean, we're just in CDW, or concrete and demolition waste. I see Thomas is still online. I have a feeling he's probably asleep, but if he wants to unmute, he's an expert. He's an expert in these regulations, and I am certainly not. Yeah. For those of you who don't know, Thomas is actually calling in from Maine, where it's approximately 4 o'clock in the morning.
Yes, there is a new one. Could you name, please, the EN? I guess the EN is the code of the regulation or something that regulates the usage of secondary substitutes.
Cementitious materials. Off the top of my head, I don't know it. Thomas actually does, but again, it looks like he's asleep, which is a good thing. We need the boss to get his beauty sleep. But Roman, maybe you and I have a session where we put all this. We put a kind of a regulations document together. It would take maybe a week, but we could probably do that fairly quickly. So we could share that with the attendees.
We will definitely anyway share the recording of this session with all the registered participants, because there are too many who couldn't join live. So we could also attach the documents over there.
Sounds good.
Yeah, please continue, and then we have another session in the end.
Okay, yeah, we only have a few more slides. So this actually is the testing. This is the performance of the material. And what this slide is showing you is the darkest. On the left, you have compressive strength, or MPa. That's how they judge concrete, how much pressure you can put on it before it shatters. So compressive strength, and then along the bottom is days. And generally the rule of thumb is 28 days, and the concrete is 90% hardened, and you can use it. So you can kind of see what the strength profile is. But in every category, there's a negligible difference. Now there's three tests you're looking at. The black one, the darkest one, is 100% virgin materials. The dark gray is 100% coarse aggregate used, and then natural sand. But the third one is 100%, so regular cement, 100% recycled aggregate, stones, coarse aggregate, and 100% recycled sand, fine aggregate. And you can see there's really no difference in compressive strength, and that's what you want from your concrete. And so anyway, people will probably ask questions about that. I'm not an engineer, so that's about as far as I want to go on this, but I can show you a few examples now. So in coastal defense, which I think you all know is a big deal here in the Netherlands, at the Afsluitdijk, we've made those butterfly blocks. And you can see on the left, somebody just raised their hand. Oh, Natalia raised her hand. Let's see if she has a question.
I'll do my best to let her speak, but again,
Natalia is the PhD student from the Ukraine at TU Eindhoven, who provided those slides of the Ukraine situation.
Do you hear me?
Yes,
Oh,
yes.
perfect.
Hello.
Thank you. Hello. I have a question regarding the previous slide. Do you have some test results already with fines from recycled concrete, not only recycled aggregate or ultrafines, I mean, as a supplementary cementous material?
Yeah, that was also my question. Good one.
We don't. So you're asking, Natalia, if we have performance about the SCM?
Yes, that's what she asked.
Yeah, we're not there yet. So we're still, I would say we're probably 12 months away from actually having an SCM that we would put out to the market for testing. Maybe a little longer, but that's because of putting together our flagship facility. Anyway, that's a longer conversation, but these following slides speak to just the aggregates. And the, well, there's really compressive strength, bulk density, but also the MKI is really the environmental benefit you get from these blocks. And those are low numbers, but that's also because we're using regular cement, et cetera, et cetera. But there is some benefit. But really what we're trying to show the world is the use of recycled aggregates in these real world environments. This is the Blue Way. It's in the north of the Netherlands where it's very cold. And this is to show that even in thawing and freezing conditions, the recycled aggregates perform well. This is actually on the TU Delft campus. It's a little bit of a convention center or meeting hall. So we've put an entire floor there. And probably the most interesting from an industrial perspective is actually these are butterfly blocks as well, but these are used by the Dutch National Railway for the lighting poles and the electrification poles along the side of the railway. So those are actually in use now. So So that's pretty much all my slides. So I just want to say again, Slava Ukraini, thanks to the Dutch Embassy, Jorg, for kind of helping to sponsor this. I'd like to thank Roman and the whole ReThink team for allowing me to participate in this event. And also want to thank Natalia, who's been supporting me. I met her a number of months ago in Eindhoven, and she provided me with all the background information on kind of Ukraine data. So in any case, thanks everybody.
Yeah. Yes, Mike, thanks a lot to you for such meticulous preparation and such a great presentation. We do have a lot of questions still, and we had also them when participants were registering. So there are a few questions from the online form, and there are a few questions from right now. I will continue in a logical order. So talking about the technology and then slowly move into the financial aspects. Please, so the next question, please compare the recycled cement with other cement substitutes, such as GGBS, fly ash. How does it compare? What is the activity rate of recycled cement? By the way, I don't know what is activity rate.
Reactivity rate. Yeah.
Okay, reactivity.
Yeah. So for me, I think we should probably have a separate conversation with our technical team for these deep dive technical questions. But I guess what I would say is, yeah, the slag and fly ash is kind of for us a target, and whoever asked that question probably knows that that's going away. And for everybody who doesn't know, slag and fly ash are the byproducts of steel mills and coal-fired power plants that you can actually recycle the waste material. Basically, you finely grind it, and it has some reactivity that you can mix in with the cement. So on the cement side, you know, the 20% replacement, slag and fly ash are actually widely used, but across multiple industries, not just in concrete. And that's a diminishing resource, right? I mean, as we transition into the green economy, slag and fly ash will become scarcer and scarcer. So kind of as a rule of thumb, well, market pricing, broadly speaking, again, 150 euros per ton for cement. Slag and fly ash are about half of that, 70 euros per ton. But the EU allows those materials to be cement replacements.
Yeah, I would also add from my side modestly that once we in Ukraine stop using coal as our energy source, there might be a shortage of that material. And when we move towards a greener metallurgy, yeah, we also have less residues. So well, I don't want to say that this cement paste that you upcycle is a completely infinite material, because if you do not demolish anything, you don't have it. But the coal.
Come on, Robert, I got to stop you. Yeah. Name me one material that's completely infinite.
Completely infinite. Water.
No, it's not.
It's not. No, but it has different states. It can be gas. It can be liquid.
Anyway, but my point is that there's going to be multiple products: slag and fly ash. You know, RCP turned into. I mean, it's like the green transition. There's not one silver bullet. There are thousands of different changes and new products and new technologies that need to be initiated. So.
Yeah, I would also ask one question from the online form. That's a good one, I guess, and it addresses the difference between targeted demolition composition that we get, and when the missile or the drone hits your building, and then you have the pile of everything. Unfortunately. So the question goes as following. Some Ukrainian experts signaled that European technologies for recycling of debris from damaged buildings may not be effective in Ukraine due to different quality of construction materials. What is your view? Is it really a major problem? And if so, what can be done to solve the problem without spending huge amounts of money?
Yeah, so that's a good question. And the answer is, my first answer has to be, I don't know, because we don't have a sample. In fact, we're sharing our samples with you guys. We probably need to get some, and hopefully early next year we will, some actually, let's say, bomb or missile damaged concrete to see what the impact is on that. Because one of the things, in fact, end-of-life concrete is our primary raw material, basically. And there's multiple different qualities of that as well. I don't know if anybody saw, but they had something called air-rated concrete from the 50s and the 60s in the UK that they thought would last 70 years, but it's now falling apart. Sort of 10 to 20 years before they thought it would. So there are different kinds of concrete, as you would expect, as there's different kinds of steel, there's different kinds of brick. So if you go back to one of the earlier slides, quality control, we're planning that into the process. We're not looking for perfection, right? I mean, perfection is the enemy of the good. And I think we're going to accept what the market wants, and we're just going to give the market different grades based upon what comes into the process. Now, I have a feeling that bomb damaged concrete is not going to be a problem. I think the earlier question about asbestos and those other materials, those are actually the problems. And we've had, Roman, as you know, some of those conversations. And I've heard, I've actually heard there isn't that much asbestos in kind of the old precast concrete buildings. In fact, it's not there, is what I was told. So I can imagine the low-rise buildings are different. But my sense is that all those old buildings that you see in the pictures, which is all that kind of Soviet era precast concrete, that might actually be ideal. Ideal. I have a feeling it'll be at least a decent raw material that can be processed without too much problem. I think the bigger issue is going to be, but again, it's not a huge issue because the Dutch have solved this. I think it's going to be getting the wood out and the plastic and all the other materials that might be in that waste. But the Dutch, there are multiple vendors here who could, it wouldn't happen overnight, but there are processes to handle that. So I would be optimistic if I could say that most of the concrete waste, will be processable without too much expense. But again, I'm not an engineer, but
no, yeah, that's true. I also want to distinguish two things now, because I read in this question a two-faceted face, because on the one hand, it's a little bit about the quality of construction materials, and that's quite easy because, well, you can really have a sample and define it. On the other hand, it's really different what you are doing in the Netherlands or in any country with the targeted demolition. So you can really dismantle everything and remove all the medicine, furniture, and when an earthquake comes or a missile comes, then everything is just put together, and then it's very difficult to have that very fine concrete separated. But even in that sense, very often the damage is related to a part of the building, and that leads to the demolition of the rest of the building. So we could say, okay, if it's too difficult to separate materials on that pile, which is laying together with plastics, medical waste, textiles, wood, etc. Okay, we leave that alone. But if we continue rebuilding the whole site and we continue with the demolition, let's make it deliberate, let's make it smart, and let's make it reuse oriented. And then, of course, we can upcycle the concrete. I will move on with the questions. We still have some. And before I move to financial ones, I want to just make sure that there is.
Can I just emphasize something you were saying but didn't really say?
Yeah.
And kind of going back to what I was saying, let's not make perfection the enemy of the good. We're not, it's not perfection that we're seeking. It's really, and I think the Dutch are showing that these recycled aggregates work. They're not, they don't look exactly like a stone, but once you've made the concrete works. And I mean, the concrete, you saw the graph, right? So,
yes.
So, maybe in the most beautiful new tower in Kiev, you're going to just use virgin aggregates because that's what the developer wants. But I think for most of the housing, most of rebuilding those sort of mid-sized tower blocks, recycled aggregates would be just fine. But
yeah.
And Ukraine has to decide that.
And that's perfectly makes sense. So I wanted to elaborate on that, and I see the question on certificates and documents that should accompany the secondary material that goes into the concrete. So what are those documents, or what are those certificates, and are they different from those that are issued when you produce virgin concrete?
So yeah, again, I'm not an engineer, so I wouldn't know the specific documents, but we could certainly find out. I mean, I know there are multiple testing organizations in the Netherlands that they do basically spot. Well, there's a schedule of testing, and they test both your equipment and your output. So the testing of the equipment happens, let's say, once a year, and the testing of the output happens sort of once per quarter, just to make sure that you're hitting the quality requirements that they want. So, and I'm talking just about the aggregates. About the concrete, I believe that's more about testing a batch. You create a mix. As somebody earlier was asking about concrete mixes. Well, there's an art and a science to that. And I believe for each construction project, you make a batch, it's tested, it's approved, and you move on. I know from conversations with people in the States, that's done on a state-by-state basis for public infrastructure projects. So like the state of Ohio or the state of Illinois will say, okay, guys, here are the mixes that you're allowed. And there's 3 mixes. And I'm not quite sure where they would go. One's for bridges, one's for roads, one's for whatever else, viaducts, water viaducts. And the state comes in, certifies the mix, and then the company has to validate that each of the mix is maintained according to whatever the mix recipe is. And then I think the government agency spot checks. So I think that's kind of the way that process works.
Yeah. Okay. And then finally, to the most interesting part, I guess, for many Ukrainians, because we are the nation of how much questions from the second minute of the webinar. What is the cost price of the secondary, concrete produced out of secondary ingredients in comparison to the virgin one?
I think it's easy. I'm not an expert on end user price of concrete, but I can answer it this way. I can tell you that, and I shared with Roman, and I mean, we could probably share some of this information, Roman, in follow-up documentation. But generally, the market for recycled aggregates has to parallel the market for natural aggregates. So again, we talked earlier, the price of coarse aggregate is depending, where you are, what part of the country, it's, 15 to 20, maybe to 25 in certain cases delivered. Now, because the government is saying you have to use recycled aggregate, there's a bit of kind of a green margin, if you will, being put on the coarse aggregates. And in fact, we're going to find this out. Our first flagship facility, fingers crossed, will be launched in about a year here in the Netherlands. We're currently negotiating with a strategic partner. So from conversations in the market, now no one signed a contract on this, it seems there's a green premium of 10 to 20% in the marketplace. When we talked to the Port of Rotterdam, they said, yes, we will pay extra for green or recycled aggregates. So we'll see if they sign that contract. So we think there is a 10 to 20% premium. Now, talking to concrete producers, they would say, yes, there is a 10 to 20% green premium that they can charge because there's demand in the marketplace, particularly at the local and regional level, for circular products. So when I was talking to one of the providers this past summer, I said, well, how much would you pay for recycled aggregates? And he said, I'm not sure. I said, well, what would you charge for the green? Because he kept talking about green concrete. He said, I think I can charge at least 15% more for green concrete. So that's kind of where the market is now. The end users are demanding it, and the supply chain is figuring it out. Does that answer the question, Roman?
Yes, it does. And we still have to find out how to, well, figure out all together with the politicians, with the businesses, and inside the society, how do we make sure that end user is demanding that, that the government is directing the way and is requiring that, or is prioritizing, at least at the level of state purchases and green purchases.
Let me add one other, and we haven't talked about this at all, but it's an important point: transport costs. Because the market, as I was talking about for recycled coarse, well, for coarse aggregate, recycled coarse aggregate, sand, recycled sand. There's kind of a rule of thumb in the Netherlands that you don't move end-of-life concrete more than 25 kilometers. And in fact, I meant to put this in the presentation just to show you the density of recycling sites. But more than one person said, oh yeah, you can't throw a stone here without hitting a recycling site. And there are over 150 recycling sites in the Netherlands, somewhere between 150 and 200. So you don't move this stuff around. And there's a big difference between the west of the Netherlands pricing for aggregates. Well, there's a difference, and the east, because the east doesn't have a lot of canal infrastructure, whereas the west does. And so the price of aggregates is cheaper in the west than it is in the east, because in the east they have to truck it around. And in fact, the end-of-life concrete is more valuable in the east than it is in the west. So when you think about this stuff is heavy, and it's a very competitive marketplace. So I mean, I know where your quarries are kind of north of Kiev, I think, and getting it out to, say, Kharkiv, that's expensive. So the value of the end-of-life concrete in the east of the Ukraine, I have a feeling will have a higher value than it will, near the quarries.
Yeah, that's true. That's true, so, and we have to address that underlines two things. First of all, upcycle as locally as possible and reuse as locally as possible. And second one, we in Ukraine, if we rebuild, let's say, Kiev region or the places that are close to virgin materials sources, then the economic viability is not that high as in the more eastern parts of Ukraine. But still, even for those parts of Ukraine, I guess we have such a low price on natural resources in Ukraine that still allows to neglect this kind of upcycling opportunities. But we have a lot of questions to answer. So first of all, the feasibility, then the mentality, like the fear to try a new thing, then this constraint of construction companies and developers and their perception that, oh, this is secondary, so it's not reliable, it's not durable. We have to prove that it's durable. Then we have to prove that it's not more expensive. So it's a long way ahead of Ukraine, but we are just embarking on it. So it's not like a big deal. We have to start somewhere. I have at least two more questions left. One is short one. Michael, could you please tell about the approximate cost of the equipment?
Yeah, I can say in round figures, a small plant is, let's say, capex of 3 to 4 million euro, and that would be 100 to 200,000 tons per year. And a larger plant, 500,000 tons per year, is probably in the range of 7 million, maybe a little more, just capex. OpEx is not that high. You don't need that many people. You need a bit of infrastructure, a bit of land. But the payoff actually it's fairly short term. It pays for itself in less than 3 years in both cases.
Mm-hmm.
The modeling that we've done.
Given
that's not using Ukraine prices, by the way, the break even. It's using Dutch and American pricing.
Yes, of course. Yeah, I do understand that. Okay, next one. Is it profitable for Dutch companies? No judgment from my side. I'm just reading the question. Is it profitable for Dutch companies to set up the production here in Ukraine and sell abroad as a business idea for investor and the possibility for Ukraine to clean up?
So, the answer is probably no, because again, my initial answer is no, because we're trying to do this locally, source locally, recycle locally, use locally. So I think what you'll find is, again, there won't be enough recycled content. You'll still need virgin content, even in the East, let's say. So recycling the concrete should really be used locally. I don't think there's enough recycled content to justify shipping it somewhere. That's just my gut feeling. I haven't run the numbers on that, but that would be my initial gut feeling.
Well, I do agree totally, but yeah, we have to answer a question. Okay, thank you for these prices. So that's more like a comment. What else? Guys, do we have more questions? Please don't hesitate to put them. We still have some time. Yeah, what are the limitations? Yeah, okay. What are the limitations for reuse of concrete? For which products secondary concrete is not tolerated? So is there a list of things in the Netherlands where you cannot use secondary concrete?
You mean the recycled aggregates?
Recycled aggregates and or recycled cementitious material.
There's not an exclusion list, no, not that I'm aware.
Okay, well, that was basically the question.
Yeah.
So please, could you elaborate on what is the yearly capacity of the equipment you have given price for? I mean the capex, and how much electricity, power, or any kind of other energy should be there, and what is the minimum like the acreage of the location?
It feels like whoever's asking this question, should get them to sign an NDA, and we can find out who they are.
Well, but I feel like you have too many potential business partners already in our webinar.
Well, I mean, let's have those follow-up calls, because I'm very interested to get Ukrainian. I mean, I'll tell the audience, Roman and I do have a dastardly plan after this call to talk to the Dutch government about a certain grant program they have that should include the concrete recycling bit, because it underpins, in fact, what they're trying to accomplish. So yes, we want to get there. So I'm happy to have a lot of these follow-up conversations. But as I said, so the question was, what's the production? So the 3 million-ish number, and that's for the Netherlands. So there may be, transport costs a little higher in the Ukraine, who knows? But that's about 100. somewhere between 100 to 200,000 tons per year processed. The higher number was for 500,000 tons per year processed. So, 500,000 tons in, and then more or less that out. But I would kind of say, again, don't forget about the SCM. If we can crack that technology, we can develop the technology that allows us to create an SCM with high reactivity, i.e. replace the cement. That's where the profit really is. The rest of it's kind of, you can make money, but it's a commodity business, the coarse aggregate and the fine aggregate, the sand and the stone, but needed. We all, food is a commodity, right? Corn, wheat, all that, those are commodities which we definitely need. So stone and sand we need, but it's the SCM that really makes the difference in the business case, if I can say that to whoever's asking this question.
Yes, so you do not specify the acreage, and you don't specify the kilowatt hours that have to be brought there.
Yeah, I don't know the kilowatt hours off the top of my head, but and I don't actually know what the footprint is, but you're going to need, I don't know how expert this person is in the recycling or the concrete business, but you need a big yard. You need a few football fields, because the equipment itself doesn't actually take up that much space, but it's the stone that takes up all the space. You need to, once you processed it, you need to store the end-of-life concrete somewhere nearby, right, on the yard, and then you need to process it, and you need to store that, and then it needs to be moved. So, we're talking, I don't know, minimum, minimum. It's hard to say. I mean, my feeling is 10,000 square meters, but that's just we're actually designing our flagship facility now. I mean, some of these recycling sites are huge because they also recycle asphalt, they recycle other things. They're also maybe adjacent to industrial waste, and so we're designing that plant now. And if someone wants to get into serious conversations, we can share that more detailed info with you.
Yeah, maybe you should come to Ukraine altogether as a startup, as a company, because the land is cheap over here. We have many football fields.
Yeah.
And the final one, I guess. I still have, I see one question, and I don't see many more. So I'm wondering, for the upcycling to become more widely implemented on the local level, should the initiative come from the government or from the below, like companies, NGOs, etc.? So what would be the ideal scenario?
Well, I mean, I think it's both, plus the buyers. At the end of the day, the buyers have the most impact. And when you say government, the government is both regulations and a buyer. So the reason the Dutch, or one of the reasons the Dutch have been able to accelerate this transition, is because everybody agrees. The buyers want it, both private and public buyers. So it's the buyers who are dictating it. Well, the government's dictating it, but the buyers are also dictating it. So it's really, the community telling the government, we want these regulations, and the community saying, we want green buildings. That's what will drive it, if that makes sense. There's no one silver bullet, but again, as I mentioned very early on in the presentation, the Dutch have a culture of recycling for a lot of reasons. But when you visit these regional players, they don't want to deal with someone on the other side of the country, because it's not circular. That everybody's looking for local players. So
yes.
Yeah.
Well, Mike, thank you very much. I think we should
pleasure.
stop. We should stop here, or do we? No, we have one more.
I see one popped up. I see one popped up.
Okay, this person is really business. So is it possible to lease the equipment? If yes, what are the conditions?
This is for a separate conversation. We have to get non-disclosed and talk about who they are and what they're trying to accomplish.
Yeah, okay. So my message to the user, BMU2 Ltd, you can email us and we will arrange a call to discuss this practical things.
Perfect. Yeah. All right. Well, Slavi Krani, thanks again, Roman, for having us. Thanks to the Dutch Embassy for supporting this effort, and let's have a follow-up conversation.
Героям слава.
Many.
Дякую. Thank you very much. This is just the beginning, but this topic is super important, and thank you for your time, Mike. Have a nice day.
My pleasure. My pleasure.
Thank you, everybody.
Thanks, everybody.
Thank you.
Bye-bye.